So now we're going to use synthetic division, which is a little bit faster way to divide polynomials. But the thing is, it only works if the denominator is linear. So it can have an x value and a number, but no x squared or x cubed or any other higher powers. Well, if the denominator were equal to 2, this thing would be undefined. And that's actually our starting place, is if x is equal to 2, this thing is undefined. With synthetic division, we start with a box, but it's turned upside down compared to long division. And this 2 that we got goes on the outside, what x is equal to. And then this polynomial is going to be put in here, but instead of putting the x's and x squares, we're just going to put the coefficients. A 1, negative 2, 1, and 1. So 1, negative 2, 1, and 1. And you don't have to put this part, but this is for the x cubed, this was for the x squared, this was for the x, and this is for the constant. Okay, now the process is, first of all, carry down this one, and then multiply these two and add it to that. So in this direction, we multiply, and then in this direction, we add. So it's going to be a 2 added to a negative 2 is 0. And then just repeat that process. A 2 multiplied with a 0 and then added to a 1. So it's going to be a 0 added to a 1. And one more time. So multiply, it's going to be a 2, and then added to a 1 is going to be a 3. And now we're done. Since we had an x cubed function divided by an x function, the result is going to be an x squared function. So this is going to be for x squared, this is going to be for x, this will be for the constant, and this will be for the remainder. So that is a 1 times x squared, a 0 times x, a 1 is the constant, and the remainder of 3. So it's a 3 divided by the original divisor, x minus 2. So this is the result, and now we should be able to compare the original function and this one and see if they have the same graph. So you've got the original function in parentheses divided by x minus 2, and then the result was x squared plus 1, and here's the remainder divided by x minus 2. And this time I think I'm going to change this to be a circle. So it's going to graph this function with a regular curve, and then this one, it will be a circle, and we need to see if the circle follows along the original graph. So then zoom 6, and here goes the original function, and now the circle should come along and trace it. It's working, so we've got it right.